Welcome to my first Trailmakers tutorial. In this series, I'll be breaking down how to build and animate complex mechs step by step, so you can follow along no matter your skill level. This is going to be a multi-part series, where each episode focuses on a different part of the build process. By the end, you'll have everything you need to create a fully functional mech. In this first part, we're starting with one of the most important elements, the mech walk cycle. I'll show you how to design and sync the legs so your mech can walk smoothly and realistically. First, we want to make sure all the joints are in place. For this setup, I used mechanical servos on the hips, but that was actually a mistake. We'll be replacing those with normal, large hinges later on. I prefer large hinges since they got updated with the linear option and they take up less space. Next, we add servos to control the movement of the upper legs. For the knees, I started out using mechanical servos because I prefer their attachment points. They make it easier to connect everything. Make sure the upper and lower leg are roughly the same size. This makes things much easier, especially for beginners. It is possible to use different sizes, but it can make the walking cycle harder to get right. Don't forget to add a joint for the foot. This will allow the mech to adjust its footing and helps make the walking motion look much more natural. Finally, add some basic stabilization so the mech doesn't fall over while walking, and place a seat so you can control and test the build properly. Make sure all the joints don't have any inputs assigned. For the mechanical hinges, I've set the speed to 2, the strength to 200, and the damping to 0 for now. We'll fine-tune these settings later once the full walking cycle is set up. Also, make sure the green arrow is pointing up. I find this makes things easier later on when we start adding and adjusting the pose. For the servos, you want the green arrow pointing backwards. If it's facing the wrong way, just reverse it by setting the speed to a negative value. I like to set the servos to an angle of 120. It gives you plenty of range of motion if you need it. For the knees, have the green arrow pointing backwards as well. That way, when we add positive values later in the logic, the knee bends inward. The foot hinge should have the green arrow pointing forward. So let's check if you got everything right. The upper and lower legs are roughly the same size. None of the joints have keybind inputs, and all the green arrows are pointing in the right directions. Everything correct? Good, then let's continue. For the mech pose, we're going to use NOR gates. They output a signal only when there's no input, so basically they're on by default. So remember, we set the upper leg servo to an angle of 120. That means if we connect a NOR gate with an output of 1, the servo will move the full 120 degrees upward. If we lower that output to 0.5, the servo only moves half of that, so that's 60 degrees. Now, 60 degrees is way too much for a standing pose, so instead, we're going to use a much smaller value. I'm going with 0.1. Add another NOR gate and connect it to the knee joints. Choose a value that you like. Since the knees only have an angle of 90 degrees, I'm going with 0.3 for now. For the foot, I'm just going to use the same NOR gate as the upper leg. And actually, I'm also going to use the same NOR gate for the hips. Now let's start creating the walk cycle. I'm using XOR gates because they allow the output to cancel when there is more than one input active. which makes it easier to layer advanced animations later without the walk cycle interfering. As you can see, I added 2 inputs into the XOR gate. When I press space, the walk XOR gate cancels. Now, if we connect the XOR gate to the upper leg, let's see what happens. Oh, that doesn't look right. This happens because we didn't adjust the output. An output of 1 rotates the leg the full 120 degrees. Let's lower it. I'm choosing 0.4 for now. Next, duplicate the XOR gate and connect it directly to the knee. I'm keeping the 0.4 from the previous XOR gate and making the first XOR gate 0.5. Just make sure the leg lifts up nice. Now duplicate the XOR gate again and connect it to the foot. Pick a value so the foot lifts up a bit. Now select all the XOR gates. The duration here determines how long the leg stays in the up position. I'm choosing 1 second for now. The pause determines how long the leg stays down before going up again. Make sure the duration and pause are the same value. Now select the XOR gates again and copy them. We're adding a delay so that after the leg stays up for 1 second, it moves backwards. Again, make sure all the values are the same. Select the first XOR gate and enter a negative value. Negative numbers make the leg move backward since we made the green arrow go forwards. The second gate I'm putting to 0 to straighten the leg out. And lastly, the foot needs to go backwards to push off the tip and roll the foot over the ground. Now this looks like absolute, but we will fix it with the fine tuning. Now copy all the XOR gates and connect them to the opposite leg accordingly. Now when we exit the builder, we can see both legs go simultaneously. Let's fix that. So the only thing we need to do is select the 3 last XOR gates and make the delay 0. After that, select the first 3 XOR gates and make the delay 1.
Now, this is the part where most people give up, but it's actually the most important step: fine-tuning. I'll show you a time-lapse of me tuning my mech, but keep in mind that every mech is different. I'll slow things down at key moments and drop in some tips along the way to help you out. Here, I noticed there was too much of a delay between steps, so I lowered the value of the XOR gates. Add a max strength gyro to keep the mech from swinging side to side. Lower the strength on the knees and foot joints to make the foot catch the ground better. Make sure the hip joint is slower than the knees. Add some max strength gyros on the side of the legs to make them less floppy. This is the part where I'm changing the mechanical hinges with large hinges. Don't forget to connect your NOR gate back again for the pose. Here I added another max strength gyro. Once we make the mech heavier, it will be less floppy. Hope you enjoyed the video. Don't forget to like and subscribe, and if you have any questions, drop them in the comments below. In the next part, we'll be improving the leg design so you can build an even cooler mech.